Hi, I am Marcelo Balbino, and I'm going to present the paper entitled Predictions of Academic Performance of Children and Adolescents with ADHD using the SHARP approach. The other paper authors are Caroline Jandré, Débora de Miranda, and Cristiane Nobre. Attention Deficit Hyperactivity Disorder, ADHD, is defined by harmful levels of inattention, disorganization, and or hyperactivity and impulsivity, excessive symptoms compared with other people of the same age and degree of development. Although there are children with ADD identified as just inattentive or hyperactive impulsive, most are of combined type. And the ADHD affects the individual life in several ways, but the symptoms are even more evident when the child enters school life. Students have with the disorder may have learning difficulties, behavior considered inappropriate to school environment, and problems in relationship with colleagues, resulting in considerable social and academic losses. And therefore, schools must adopt the appropriate strategies to develop students with ADHD. However, in general, institutions have difficulty dealing with students with the disorder. Consequently, this scenario creates a context of low students' performance. On the other hand, it's believed that ADHD is not a definitive factor of low performance. Thus, other features may enhance or minimize the damage caused by the disorder. Therefore, it's necessary to raise the features that interfere with the ADHD student performance to help parents, educators, and other professionals direct the actions for better results for students. We receive a data set with 266 Brazilian students aged between 6 and 18 years, of which 196 were with ADHD. This data set was generated through questionnaires and interview applied by the medical team of Pediatrics Department of Brazilian University. This data set contains 225 features, including personal, gestational, medical, socioeconomic, parental care, education, family data, and scores of individuals in arithmetic, writing, and reading tests. Based on these scores, students were classified as having lower or higher performance in these disciplines. And at this point, machine learning emerges to turn this data set in a source of knowledge. Machine learning is an important field of artificial intelligence that help computers on experience-based modeling and accurate predictions of future events. The advancement of machine learning methods has enabled models that typically achieve high predictive capacity. However, in many scenarios, having a model with high predictive performance is not enough. For example, in this work, predicting whether a student will have higher or lower academic performance does not entirely solve the problem. It's necessary to understand the model's decision to have confidence and act based on its results. Therefore, it is essential to interpret the model results. That's why we use the SHARP approach. Sharply additive explanation is an approach to interpreting predictive models based on comparative game theory. The model, basically from the prediction model, SHAP generates an explanation model that allows explaining the prediction made. Therefore, this work aims to discover through machine learning and SHAP approach which features have the most significant impact on the student's performance with ADHD in arithmetic, writing, and reading. The main steps of the work were one per processing. When we received the data set, it was not read to submitted to the machine learning algorithm. It was necessary to treat the data set. We did the manual random separation of 15% of instance of each class to perform the testing. Then balancing the remaining 85% of data using split subsample for training and validation. Then is period maintain with models based on 4 algorithms with decision tree, neural network, SVM, and random forest. The proposal is to develop the interpretability of only the models with the best performance in each discipline. The models were implemented in Python, and precision recall and visual methods were used to assess the quality of the models. I won't detail all results, but you can see that random forest, red bars, performing well across all disciplines for both class. And therefore, we decided to perform the model interpretation with random forest for all scenarios using SHAP. We developed several plots. We choose some graphs to show. In the paper, there are other graphs and discussion about them. So, starting with arithmetic, this is one of possible plots available in SHAP called summary plot. The plot presents an overview of effects of the main features in predicting performance in arithmetic for lower class. This plot orders the features by their importance. So Raven Z is the feature of more significant influence in predicting the student performance in arithmetic. Then we have model schooling, social class, school type, and if the student has ADHD. Each point present on the line for a given feature, Raven Z, for example, represent an instance and therefore a student impacted by this feature. If a point is on the right side of the central axis, it means that this feature is influenced the student to the lower class. The point color represents the value of feature in instance, red to high values and blue to low values. And the farther away from the central axis, more significant the impact of the feature on that student. For example, this student, represented by this point, is more impacted by Raven Z than a student near the central axis. And talking a little about each related feature, Raven Z is an IQ test. The interpretation that we can make is that lower IQ test in blue lead to predicting performance as lower. And about model schooling, models with higher schooling in red help their children's school performance it's very interesting. As well, higher social class families. Um, about school type, private schools help ADHD students' performance. Private schools are in blue, in red. And finally, ADHD, the graphic is indicated that ADHD is a complicating factor for school performance, but there are other features more important than the disorder. This graph allows us to visualize a particular student predicted to perform lower in arithmetic. The features that influence the prediction for the lower class are shown in red. Those that distance the prediction for the same class are in blue. It's noted that the low level of parents schooling and the school type, public school, bring the student closer the lower class. On the other hand, having a good score on the Raven Z test distance him from the lower class, but not enough to change the prediction. Now, we present the summary plot for writing. Again, Raven Z appears as the most relevant feature, as in arithmetic features such as school type, mother's schooling, and have an ADHD appear with similar behavior for writing, although in different orders of importance. The sex attribute emerge with significant importance according to the graph. There is an advantage for female. Now, the summary plot for reading shows that Raven Z was again the most relevant feature. The school year is a second most important feature. It's possible to interpret that the students improve his reading performance over the years. It's reasonable to assume that the student's high is related to school year. And finally, we observe the relevance of future mother's age, in which older mothers, red points, contributes to the student's performance. And finally, the use of shape approach for interpretability proved to be helpful. Its resource allowed to deepen the model's understanding and identify the relevant features to academic performance. About the features highlighted by the model, the experiments indicated that the student's IQ, representing the database by the Raven Z, is the feature with the most significant impact. Then the mother's schooling, being a private school when student social class were frequently highlighted features. This result indicated that the school and family support positively influence the students' academic performance. In all disciplines, the students having ADHD emerge as an important feature, but in general less relevant than the previous feature. The quotes using this presentation. We thank the institutions that contribute to this work. And finally, these are our contacts, and it will be a pleasure to receive any question about the work. Thank you so much.